Hello everyone. In the previous session we have discussed the concept of probability and we have solved some of the problems. So let me continue the problems on probability. So here is a problem. So given that probability of A is equal to 1 by 4. First let me write down the given data. Given that probability of A is equal to 1 by 4. Similarly probability of B is equal to 1 by 2. Probability of A intersection B is equal to 1 by 8. We need to find probability of A union B. Fine. So in the previous class I have given the notes, in the sense properties or laws of a probability I have given. Please go through that list. Here is a list, so you can go through this list and check whether which formula we have to apply. See here, probability in the given problem, probability of A is given, probability of B is given, and probability of A intersection B is given. We need to calculate A union B. Fine. So look at the relation which connects the union and intersection. It is fifth relation. So I am using fifth one. That is, we know that probability of A union B is equal to, continue the problems, please take the running notes, plus probability of B minus probability of A intersection B. This is the formula, property of probability that we have studied in a previous session. Fine. Now we need to calculate probability of A union B. So let us substitute the values. Probability of A union B is equal to, probability of A is 1 by 4, probability of B is 1 by 2 minus probability of A intersection B is 1 by 8. Now I am telling you once again, you should not use the calculator to simplify this. Fine. Why? Because you have to keep the answer in terms of fraction. So let me take LCM for 4, 2, 8. So 4, 2, 8. So if you're going to take LCM for these, you're going to get 2 2s are 4, 2 1s are 2 4s are 8. Hope so everybody knows it. Anyhow, I'll just tell one problem. 2 2s are 4. Again 2 1s are. So total LCM is 2 2s are 4, 4 2s are 8. So let me take 8 as an LCM, multiply 8 here. So 4 1s are 4 2s are. So you will get 2 here, again 2 4s are 8, so here you will going to get 1. So let me simplify. You will get probability of A union B as 2 plus 4 is 6, 6 minus 1 is 5, 5 by 8. Therefore probability of A union B is 5 by 8. Hence the solution. So before going to start the next problem, so you just copy down as a note. So take the note. You have already learned this concept in a sets in a first semester, right? So this represent A complement or A bar. So A intersection A bar is null set. Universal set. Universal set. So in case of probability, if you want, you add that also. In case of probability, universal set is equivalent to sample space. Fine. So whenever you are going to take A intersection with its complement, you will get universal set. So any set with its complement, intersection of A and its complement is null set. A union null set is A. So you have already proved all these properties in your first semester. Fine. And this De Morgan's law as well you are familiar with, where we are using complement notation is something like this. Instead of this, we are going to use this. So this is a representation for complementation of a set. So A union B whole complement is equal to A complement intersection B complement. Second law is A intersection B whole complement is equal to A complement union B complement. Now you need to remember this Venn diagram to prove one of the important theorem, as well as for concepts solving problems based on it. So as you already know that the circle portion which I have shaded in red pen, that is in red ink, you can note that dark circle, darkly shaded region represents only B. Why? Because a part of B is included in A intersection B, right? Similarly, part of A is included in A intersection B. If you want to calculate only A, so you have to subtract this overlapping region from first circle. If you subtract this overlapping region, you will get only A. So only A we can obtain by subtracting this A intersection B from the set A. Similarly, this represents only B. We can obtain this set by subtracting from whole B, you have to subtract A intersection B. So that is what I have written here. Only A in the sense A minus this shaded region. So, similarly, only B in the sense B minus this shaded region will give you only B. So you have to remember this. So further we will be using to solve the concepts. Clear? Now let us solve one more problem. So here is the problem. First one is, first let me write down the given data. Given data is probability of A is equal to 1 by 4. Similarly, probability of B is equal to 1 by 2. probability of A intersection B is 1 by 8. Fine. First what we have to find is probability of A or B. As I already told you in the note point, I have clearly given whenever you have union you have to use R. So I have to find P or probability of A or in the sense union. Find intersection in the sense and. So you have to find A union B for the first question. So A union B, you already know the formula that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. This is the formula we have as per the laws of probability. Now let me substitute probability of A union B is equal to probability of A is given 1 by 4, probability of B is also given 1 by 2 minus probability of A intersection B is 1 by 8. Now you can take the LCM. So probability of A union B is equal to LCM for 4 to 8. 2 2s are 4. I'm sorry. 2 2s are 4. 2 1s are 2 4s are 8. Again 2 1s are 2 2s are. Again it is 1. 2 2s are 4. 4 2s are 8. So 8 is the LCM. When you take 8 as an LCM, 4 2s are 8 plus 2 4s are, again it get cancelled. You will get 1. So after simplification it will give you 5 by 8. That is probability of A union B is 5 by 8. Fine. Now look at the second sub question. What we have to find is P probability of not A and not B. Probability of not A and not B. First we have to convert it in terms of mathematical form. So it is probability of, as I already told you, complement event definition. What it says, if A is an event, A complement represent its A bar represents its complement. It is not an event. Fine. Which is not happening, right? So A bar represents its complement. A not A in the sense complement. And whenever you have and, you have to use intersection. Remember, whenever you have and, intersection, or in the sense union. So intersection, not B in the sense B bar. So you have to calculate probability of A bar intersection B bar. Now I can rewrite the same as, see here, probability of A union B whole bar, because I'll just write reason here. By De Morgan's law, what is the De Morgan's law says? A union B whole complement is equal to A complement intersection. In the sense of complement you have to write like this, intersection B complement. So I can write A complement intersection B complement as A union B whole complement. Fine. Now we have already studied the concept of complementation. That is, relation between complementation is, we know that probability of A plus probability of A bar is equal to 1. So similarly probability of A bar can be written as 1 minus probability of A. Right? Now in place of A bar what we have? Probability of A in the sense A union B whole bar is equal to 1 minus probability of A union B. Fine. Now why? Because we need to find probability of A bar intersection B bar. So it is same as, we don't know probability of A bar here and B bar here. So we are going to apply the properties. So I can write this by using De Morgan's law. Now what I have done is I have considered the relation between any event A and its complement. So P of A plus P of A bar is equal to 1. So in place of A what I have done is A union B whole bar I have written. So I have applied this property to this term. So I have obtained this. Meaning is, see here, we need to find probability of A bar intersection B bar. So it is equivalent of finding P probability of A union B whole bar. So we have already calculated P of A union B. It is 5 by 8. Fine. So probability of A union B whole bar is equal to 1 minus 5 by 8. If you want, you can write this as 1. I have applied De Morgan's law. So I have written this. Now let me take the LCM. So you will get 8 minus 5 by 8. It is 3 by 8. So the probability of probability of A union B whole bar is equal to 3 by 8. Therefore from 1, I am going to substitute this value in 1. Therefore probability of A bar intersection B bar is equal to, what is the value here? It is 3 by 8. This is what we have to find, that is probability of not A and probability of not B. Clear? So this is the second sub question. Now we have to find the third question. So third question I'll just do here. Third question is what we have to find, probability of not A, in the sense not A, as I already told you, not A in the sense A bar, not B in the sense B bar, not A union B in the sense A union B whole bar. Fine. So let me find probability of A bar. As I already told you, relation between probability of A and probability A bar. Probability of A bar is given by 1 minus P of A. 1 minus P of A. So it is 1 minus probability of A is given in the problem itself. It is 1 by 4. So 1 by 4. Therefore, probability of A bar is equal to LCM is 4. 4 minus 1 by 4. It is 3 by 4. Therefore, probability of A bar is equal to 3 by 4. Hope so it is clear, right? So first sub question I have done here, and second sub question here, third sub question is here. Hope so it is clear. So let me solve one more problem. So here is the problem. It is important question asked in 2018. We just copy down. If A and B are two events with probability of A is equal to 5 by 8, probability of B is equal to 3 divided by 8 it is, and probability of A union B is equal to 1 by 8, then we have to find all these four. So let me solve here. Solution. First let us write the given data. Given probability of A is equal to 5 divided by 8. Probability of B is equal to 3 divided by 8. Probability of A union B is equal to 1 divided by 8. Fine. Now let me solve first one. Probability of A and B. As I already told you, whenever you have and, you have to use union. Whenever intersection. Whenever you have R, you have to use union. R in the sense union, and in the sense intersection you have to find. Fine. So we know that I can write this as A intersection B is equal to question mark. We know that a relation between intersection and union by the laws of probability. We can write probability of A union B as probability of A plus probability of B minus probability of A intersection B. Now A intersection B is unknown, that we need to find out. So let me keep as it is. Anyhow, probability of A union B is given. It is 1 by 8. Probability of A is 5 divided by 8 plus probability of B is 3 divided by 8 minus probability of A intersection B. Now let me shift the terms. I'll just shift minus probability of A intersection B to from right hand to left hand, and I'll shift 1 by 8 other side. I'll keep as it is. 5 by 8 plus 3 by 8. When you shift this, you will get minus 1 by 8. Now probability of A intersection B. Let us take the LCM. So LCM for 8 is 8 only. So you will get 5 plus 3 minus 1. 5 plus 3 is 8. 8 minus 1 is 7. So probability of A intersection B is 7 by 8. So this is the solution for the first one. Fine. Now let me find the second one. Second one, what is the given? That is probability of not A we have to find. Not A in the sense, as I already told you, not A represent A bar. Fine. Not B in the sense B bar. So we have to find probability of A bar. We already know that the relation between complement and the event PA is P of A plus P of A bar is equal to 1. P of A bar we need to find out. P of A is 5 by 8. Plus probability of A bar is equal to 1. Now probability of A bar we need. So 1 as it is, shift plus 5 by 8, you will get minus 5 by 8. Now take the LCM. So you will get 8 minus 5 is 3. 3 divided by 8. This is the probability of A bar. That is not A. Fine. Now let me solve the third one. Third one is probability of not B. You should not divide like this. You have to write one below the other. Since there is no space to write, so I am writing here. Probability of not B. In the sense, we have to find probability of B bar is equal to question mark. So I'll just write the relation directly. That is probability of B bar is equal to 1 minus probability of B. Fine. Probability of B bar is equal to 1 minus probability of B is 3 divided by 8. So probability of B bar is equal to 8 minus 3 by 8. 8 minus 3 is 5. Therefore, probability of B bar is 5 divided by 8. Clear? Now, similarly, let me calculate the fourth one. Fourth one, I'll just do here only. Fourth one is probability of not A and not B. First you just write down it in a mathematical form, then you will get an idea to solve. Now probability of not A in the sense probability of A bar, and in the sense intersection, as I already told you, A bar intersection not B in the sense B bar. Fine. Now we have already know that from the De Morgan's law says that what we can write is A union B whole complement can be written as A complement intersection B complement. So I can write this as probability of A complement intersection B complement. Fine. Now why? Because we know the data of it. Now we have probability of A bar intersection B bar is none other than probability of A bar intersection B bar, right? By De Morgan's law I have written it. Now I'll just continue here only. Now we know that what is the relation between A and its complement. Just now I have written P of A bar is equal to 1 minus P of A, right? Now replace A by what you have in place of A. I'll just replace A by A bar intersection B bar. Clear? I'm sorry, I have not replaced here. Union I have to do, right? See here I have applied the De Morgan's law, so I can write this term as whole bar. So this term as whole bar I have to write. So whole bar. Now let me replace A with, we have to apply the property of complementation here. So let me replace A by A union B whole bar. I'm sorry, it is union. I'm extremely sorry. I will not notice that. So I can write P of A union B whole bar is equal to 1 minus P of A union B. Shall we write like this? Yes, we can. Right? Why? Because we know the value of probability of A union B. It is given in the problem itself, so we can easily calculate. So that is why I have applied De Morgan's law. Now probability of A union B whole bar is equal to 1 minus probability of A union B is 1 by 8. Now do cross multiplication. 8 minus 1 is 7 by 8. Clear? Therefore probability of A bar intersection B bar is equal to 7 by 8. Hope all the three questions are easy. Let me explain fourth question once again. Probability of P naught and not B. Not A and not B. Not A in the sense A bar, and in the sense intersection, not B in the sense B bar. So I can apply De Morgan's law for this theorem. This is what the De Morgan's theorem we have. So I can replace this with this. That is whole bar I can replace. So this is whole bar now. Fine. Now I have written this statement once again by replacing it whole bar. Now by the relation between any event and its complement, we can write P of A bar as 1 minus P of A. Now let me replace A with A union B whole bar. Fine. So in place of A union B whole bar, I have written in place of A bar. Fine. So in place of A bar I have done this. So A will be P union B. So I have substituted the value of P of A union B. It is given in the problem. So this is what the solution is. So you just take a screenshot and just copy this problem to notes. While solving, please try to solve yourself. Then you will understand the concept. Fine. Hope so it is clear. Now let me solve one more problem. So here is the next question. It is also important question. It has been asked for 5 marks. So here we can note that probability of A is given. First let me make a list of given data. Probability of A is 1 by 2. Probability of B bar is given. While writing, please make sure whether complement is given or a event is given. So P bar is 5 divided by 8. P of A union B is 3 by 4. Now let us find first one, that is P of A intersection B. So as we already know that to find A intersection B or A union B, we have only one formula, that is P of A union B is equal to P of A plus P of B minus P of A intersection B. Now you can find A intersection B by using this formula when we have all these values known. So P of A is given, P of A union B is given, but P of B is not given. So we need to find P of B first. Fine. So we since P of B bar is given, I am going to use the relation between event and its complement. So I can write P of B bar plus P of B is equal to 1. Now we need the value of P of B. I'll just keep P of B here only. So I'll shift P of B bar 1 minus P of B bar. Now P of B is equal to 1 minus probability of B bar is 5 by 8. So on simplification we get probability of B as 8 minus 5 is 3 by 8. Now substitute this to get the solution for the first problem, that is P of A union B is equal to probability of A is 1 by 2 plus probability of B, now we have calculated, it is 3 by 8 minus probability of A intersection B, we don't know, so we have to calculate it. Anyhow P of A union B is given, it is 3 by 4. So 3 by 4 is equal to 1 by 2 plus 3 by 8 minus probability of A intersection B. Now we need probability of A intersection B. I'll shift this term, so we'll get positive. Now since you have positive, I'll shift this term, you'll get negatives. That is 1 by 2 plus 3 by 8 minus 3 by 4. Now take LCM for 2, 8 and 4. So when you take LCM, you'll get 8, 4 plus 3 minus 6. Hope so LCM is clear for you. So probability of A intersection B is 4 plus 3, 7, 7 minus 6 is 1. So you will get 1 by 8. This is the solution for the first sub question. That is probability of A intersection B. Similarly, we need to find probability of A bar intersection B bar. So let me do the second one. Probability of A bar intersection B bar. Right? So meaning is probability of A bar in the sense probability of not A, intersection in the sense and not B. Right? So I'll just apply the De Morgan's law. So we know that by De Morgan's law, how can we write A bar intersection B bar as A union B whole bar. So this is the De Morgan's law we have, right? Now let me since I can replace here now, so let me write here A bar intersection B bar is equal to probability of I'll just write this term as this, that is A union B whole bar. Why? Because as A union B is given in the problem, we have to consider the complement relation. So how can I write this as, because see here probability of A plus probability of A bar is equal to 1, or else probability of A bar is 1 minus probability of A. Right? So 1 minus probability of A. Here in place of A bar what we have? A union B. So I can write this as 1 minus probability of A in the sense A union B. So probability of A bar intersection B bar is equal to 1 minus probability of A union B is 3 by 4. So let me cross multiply. 4 minus 3 is 1, 1 by 4. Therefore probability of A bar intersection B bar is 1 by 4. Clear? Now let me solve the third sub question. What we have to calculate is probability of A bar union B bar. I'll do third one here. So third sub question. Look at the third question. What we have to find is probability of A bar union B bar. Again we can use De Morgan's law, right? As we done in the second case, we have to follow the same. Here in place of intersection we have union, that's all. By De Morgan's law, we can write A bar union B bar as A intersection B whole bar. Right? This is by De Morgan's law. Now let me consider this P of A bar union B bar. Now I can replace A bar union B bar as A intersection probability of A intersection B whole bar. Now we have to apply complementary relation, that is P of A bar is equal to 1 minus P of A. Clear? Now I can write in place of A what we have? A intersection B. So I can write this as 1 minus probability of A intersection B. Therefore probability of A bar union B bar is equal to 1 minus probability of A intersection B. We have already calculated it from first question. First sub question we have done probability of A intersection B. It is, so let me take cross LCM. So 8 minus 1 is 7 by 8. Therefore probability of A bar union B bar is equal to 7 by 8. So suppose if in the exam, if first question is not asked, if they asked you to find only this value, again you have to find A intersection B. That is, this value you can easily find. It depends on the conditions given. That is, whatever the values is given, based on that you have to use the formula. Clear? So this is the third question. Now let me solve the fourth one. Fourth one is probability of A bar intersection B. We don't have bar for B. A bar intersection B. Remember, while writing the problem also care has to be taken whether the event is given or its complement is given. Otherwise everything goes wrong. Fine. Anyhow, let me explain. So probability of A bar intersection B, meaning is probability of not A and B. Right? Intersection in the sense and B. This problem is quite different comparatively. So P of not A and B we need. Not A and B is meaning is, so I'll just write it using Venn diagram so that you'll understand clearly, as I already explained this concept for you. See here, suppose if this is A, this is B, this will be A intersection B, right? A intersection B. So this portion represents only A. right? So this represents only B. Only B in the sense which does not include A, not A and only B, right? I'll just show you the note point. See here, you can look at this diagram as I already given this in the note. So this portion represent only A, this darkly shaded region represent B. So lightly shaded region in both the colors represent A intersection B. Now you can just see that not A and B, not A and B in the sense it should not include A. So A, here also A is included, so it should not include A. Only B you have to consider, right? Not A and B meaning is you should not include A. Then what you left with is only B, right? Not A meaning is A is not there. So what is the remaining thing? Is only B. So I can write this as P of only B. Fine. Now as I already explained, only B in the sense, how can I write it as B in the sense you have to subtract this mixed region. So only B is none other than B minus this mixed region is A intersection B. So I can write only B as B minus A intersection B. Probability of B minus A intersection B. Clear? Now as per the property of probability, I can split the probability inside the term. So I can write like this. Therefore probability of A bar intersection B is equal to probability of B minus probability of A intersection B. Now as we already calculated, the probability of B is 3 by 8. So let me substitute 3 by 8 minus probability of A intersection B is 1 by 8. So I will substitute here. Now let us take an LCM. So 8, 3 minus 1 is 2. So 2 by 8, 2 1s are 2 4s are. So you will get 1 by 4. Therefore probability of A bar intersection B is 1 by 4. Fine. Now fifth one we have. Fifth one also somewhat same. Probability of A intersection B bar. I'll just do here probability of A intersection B bar. Fine. So it is visible, right? Yeah. Probability of A intersection B bar. Now meaning is probability of only A intersection, meaning is similar to this problem. Intersection in the sense and B bar in the sense not B, right? Only you just leave it A and not B meaning, right? So you now again you look at the Venn diagram. See here, if you want you can write here also only B. This is only A. Fine. So you can see here probability of A and not B. Not B in the sense you should not include B. See here lightly shaded region in the both the colors represent A and B. Both A and B it represents. So we should not include it. Why? Because B is included here. B is also included here. We should not consider B. Not B in the sense we should not consider the region where B is present. So B is here also B is there. Here also B is there. So we should not consider these two portions. So remaining portion is this. So only this in the sense only A. How can I write only A as entire A minus this common region, right? So only A. I can write this as probability of A only A. A and not B in the sense you should not consider B. That's all. So only A in the sense A minus A intersection B. Now I'm going to split the probability. You get probability of A minus probability of A intersection B. Fine. Probability of A intersection B bar is equal to, what is the value of probability of A? It is given in the problem. It is 1 by 2. So I'll just substitute 1 by 2 minus probability of A intersection B. I have already done. It is 1 by 8. Fine. So take an LCM. It is 8. You will get 4 times. That is 4 minus 1. You will get 3 by 8. Clear? Therefore, probability of A intersection B bar is equal to 3 by 8. Hence the solution for all the 5 sub-questions. Hope so everything is clear for you. If you have any doubts further I'll clarify. So only these two problems are quite different. Clear? So here is the next question. Here given is A intersection B, A union B and A complement is given. We have to find probability of A, probability of B as well as A intersection B bar. So let me first write the given data. What is the given data here? Probability of A union B. It is 7 by 8. Next probability of A intersection B is given 1 by 4. Next probability of A bar is given. It is 5 by 8. So first one is we have to find probability of A. As I already told you, since complement is given, we need to use the relation between event and its complement. It is given by complement is equal to 1 minus probability of event. Fine. Now P of A bar is given. It is 5 by 8. Right? 1 minus probability of A. We need to find probability of A. I'll just shift here. P of A is equal to 1 minus 5 by 8. I have just shifted the terms. This term to here, this term to there. Now I can write 8 minus 5 is 3 divided by 8. Therefore, probability of A is 3 by 8. Next is similarly, let me find probability of B. Second one, we have to find probability of B. Fine. But you can note that to find the probability of B, we don't have its complement here to find probability of B. So we have union and intersection and probability of B. So we have to make use these two given data in order to find the unknown. Within a given data only you have to find the unknown. So we know that formula for connecting union and intersection is P of A union B is equal to P of A plus P of B minus P of A intersection B. Right? Now A union B is given, it is 7 by 8, which is equal to probability of A is 3 by 8 plus probability of B is, we have to calculate, so let me keep as it is, minus A intersection B is 1 by 4. Now let me shift the terms. So probability of B I'll keep here, remaining terms I'll shift. So you will get minus 3 by 8 plus 7 by 8. Now minus 1 by 4 will become plus 1 by 4 will be equal to probability of B. Now take an LCM for 8, 8 and 4, you will get 8 only. See here 8, 8, 4. LCM you just going to take 2, 2 4s are, 2 4s are, 2 2s are. Again 2, 2 2s are, 2 2s are, 2 1s are. Again 2, 2 1s are, 2 1s are, 2 1s are. 2 2s are 4, 4 2s are 8. So 8 is an LCM. So if you take 8 as an LCM, you will get minus 3 plus 7 plus 2 is equal to probability of B. Now 7 plus 2 is 9. 9 minus 3 is 6. So you will get 6 divided by 8. Or 2 3s are 2 4s are. Therefore, probability of B is equal to 3 by 4. Fine. Now, at last you have to find A intersection B complement. Just now I have solved the same problem. So you have to make use of same concept, P of A intersection B complement. So as I already told you, A intersection B complement in the sense P of A and not B. See here, A and not B. Not B in the sense you should not contain you should not consider a region containing B. See, B is present in this region and this region. So you have to leave this region. Only region is containing A. That is only A. How can I write only A as? Each and every time no need to write only A. How can I write only A as? A minus A intersection B. Clear? I'll just write probability here. Now probability of A, I'll just split this, probability of A minus probability of A intersection B. Now what is the value of probability of A? We have already calculated, it is 3 by 8 minus probability of A intersection B is 1 by 4. Therefore probability of A intersection B complement is equal to, let me take LCM, 8 is an LCM, so you'll get 3 minus 2 in the numerator, so it is 1 by 8. Clear? Therefore probability of A intersection B bar is equal to 1 by 8. Hence the solution. Hope so it is clear. So only thing is you need to remember this different concept through Venn diagram. That is why I have given that in a note point. So this is the problems based on the properties of probability. Now let me prove some of the properties. As I already given these properties in a list, so we have to prove the same. So first one is probability of A bar is equal to 1 minus probability of A. This gives the relationship between probability of event and its complement. So after completion of 11th problem, you just write down prove the following and write down this first question. Fine. Now coming to the proof, as I already told you at the beginning of the session, see here, A intersection A bar is equal to, A union A bar it is. I'm extremely sorry, you just make it as union there. That is when you combine a set and its complement, you will get U, universal set. So in case of probability, universal set is equivalent to S. Meaning is, we can write A union A bar as sample space S. I just repeat once again, A union A bar is equal to sample space S. In case of set, it is equal to universal set. Fine. So I'll just consider that. We know that A union A bar is equal to yes. I'll give you, if you want, I'll give you simple example. See, if I'm going to toss a coin, sample space will be either you will get head or you will get tail, right? Suppose, let me consider an event A as getting head. Fine, what is its complement? In the sense, A bar, A is a event of getting head. Its complement is not getting head. Not getting is equivalent to, say, getting tail. I'll just repeat once again. When you toss a coin, sample space will be all the possible output. Either it should be head or it should be tail. Let me consider event A as getting a head. A bar is complement. Getting a head is event. Its complement is not getting head. Not getting head is same as getting tail. So when you combine these two, that is union of A union A bar. When you combine these two, you will get H comma T. That is head and tail. So that is what the sample space is. So I can write A union A bar as equal to yes, as it is equal to the required sample space. Clear? Now where I'll just write one statement where S is sample space. And remember, one more note point I have already given in the second in the first video of probability of sample space is always equal to 1. If you are going to find probability of each and every possible output and you add all the sum, you're going to get 1. I have already given it in a note point. Please go through that. And now S is a sample space, you just write down. Now let me consider probability on both sides of a above equation. So you will get probability of A union A bar is equal to probability of S. Fine. Now we know that what is the formula we have. That is, if you want, I'll just write here. See, here is the formula list. I have clearly given that probability of sample space S is equal to 1. Fine. Now what we need to find is probability of A union B. It is something like A union B. So I'll just write that property. We know that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Similarly, I'll just write probability of A union A bar. Replace A, B with A bar. That's all. So you will get probability of A plus probability of A bar. Similarly, A bar minus probability of A intersection A bar. Fine. Now I'll just substitute. Let me call this as equation 1. This as 2. So equation 2 in 1. Equation 2 in 1. So LHS will be probability of A plus probability of A bar minus probability of A intersection A bar is equal to probability of S. As I already told you, probability of S is 1. Before that, A intersection A bar is what is the value of A intersection A bar? I have already told you at the beginning of this session. Whenever you are going to take either intersection with its complement, that is A intersection A bar, you will get null set. Why? Because there is no common event. See here, if A is an event of getting head, A bar is getting tail. So do we have any common? We don't have any common nature between those two, right? So A intersection A bar is always equal to null set. Remember, so if you are going to take probability on both sides of this, you will get, we know that what is the value of probability of null set? It is 0. Therefore, probability of A intersection A bar value is 0. Now, we also know that probability of S is 1. So, substitute this in above equation. Therefore, above equation become probability of A plus probability of A bar. What is the value of this? Minus 0 is equal to probability of S is 1. Therefore, probability of A plus probability of A bar is equal to 1, or probability of A bar is equal to 1 minus probability of A. Hope so it is clear, hence the proof. Fine. So you just practice so that you will understand well. Clear? Now coming to the second one. Anyhow, this point is also I have given in a property. So this property I have proved now. So this is given. It is probability of null set is equal to 0. So let me prove. Let me show you how the probability of null set is equal to 0. So proof. Now we already know that if you combine any set with a null set, you will get the same set, right? So for example, if I am going to consider a set A with an element 1, 2 and pi B as a null set pi. If you are going to combine A union with null set, you will get A only, right? Element 1, 2 only you will going to get. So we know that A union null set is equal to A. Let me take probability on both sides. So you will get A union of pi is equal to probability of A. Now let me split this as per the properties. Probability of A union probability of null set is equal to probability of A. Now union in the sense, I can when you're going to split the probability, as I already told you, union will become plus for n number of mutual distant sets. See here, whenever you have unions, when you're applying probability, this union will become plus as per property 4. So I can write this as plus. Now probability of A and both sides get cancelled, or else let me write one more step. Probability of null set is equal to probability of A, just shift it, minus probability of A. Therefore probability of null set is equal to, what you're going to get? 0. Hence proved. Clear? So here is the next property. If A and B are two independent events, then prove that A bar and B bar are independent event. So before proving this property, I'll just give you a glance. See here, whenever you just look at this sixth point, whenever we have two events, that is independent event, if A and B are two independent event, we can write probability of A intersection B as probability of A into probability of B. This concept you have to remember. That is, if A and B are independent event, probability of A intersection B is equal to probability of A into probability of B. I'll just write it here. See here, proof. Given A and B are two independent event. Therefore, so just now I told you, if A and B are two independent event, we can write probability of A intersection B is equal to probability of A into probability of B. Fine. Now what we have to prove is, to prove A bar and B bar are independent. A bar and B bar are independent. So what we have to prove is, that is probability in place of A and B, what we have to prove? A bar and B bar. We have to prove that A bar intersection B bar is equal to probability of A bar into probability of B bar. Am I correct? See here, if any two events A and B are independent, then we can write this condition is holds good. That is, probability of A intersection B is equal to probability of A into probability of B. Now we have to prove that A bar and B bar are independent. So in place of A bar should be there. In place of B, B bar should be there. So let me prove that. Let us consider De Morgan's theorem. By De Morgan's law, what we have? We have A union B whole complement is equal to A complement intersection B complement. In order to get this term, I have considered this property of a De Morgan's law. This law of a De Morgan's law. We have two laws. One for intersection. If you are going to take intersection, you will get individual union there. So, but we need intersection. So that is why I have considered this law. Fine. Now let me apply probability on both sides. Probability of A union B whole bar is equal to probability of A bar intersection B bar. Am I correct? Now let us take this as equation 1 and let me take this as equation 2. Fine. But we also know that, how can I write a probability of A union B whole bar? By using the property of because probability of A bar is equal to 1 minus probability of A. Relation between event and its complement is P of A bar is equal to 1 minus P of A, right? So P of A union B whole bar, how can I write? In place of A bar, what we have? A union B whole bar. So I can write this as 1 minus P of A union B. Am I correct? Probability of A bar is equal to 1 minus P of A. In place of A, what we have? A union B. So I have applied this property. Am I correct? Now let me consider this as 3. Now I will substitute 3 in equation 2. So when you substitute, you will get A union B whole bar as 1 minus probability of A union B, which is equal to probability of A intersection A bar intersection B bar. Now you know the formula for P of A union B, right? I have already given in the list. P of A union B is P of A plus P of B minus P of A intersection B. So let me write it. P of A plus P of B minus P of A intersection B. which is equal to P of A bar intersection B bar. Remember, while putting the bracket you have to take care. Why? Because you have minus sign here. Clear? Now let me multiply inside. Before that, what I'm going to do is I can replace P of A intersection B by using equation 1. Now substitute equation 1 in the above equation. We get 1 minus, open the bracket, probability of A plus probability of B minus probability of A intersection B is probability of A into probability of B. Why? Because they are independent event. We can replace it, which is equal to probability of A bar intersection B bar. Now I am going to multiply minus inside. So probability of A minus probability of B, minus of minus is plus probability of A into probability of B. Now I am going to group this term in order to take a common factor. That is, I will group these two terms as one group, that is 1 minus P of A. Now I am going to take common in these two terms. Minus P of B is common. Right? When you are going to take minus as a common, you will get plus 1 plus probability of A. Since you are taking minus common, so this plus will become minus. If you multiply this minus inside, you will get back previous steps. Here minus P of B, minus into minus is plus P of A into P of B. One and the same, so you will get 1 minus P of A. Again, what is the common term? 1 minus P of A. So I'll just write this A intersection B bar, probability of A bar intersection B bar. Now let me take common as 1 minus P of A. I'll just take common term. So what you left with, when you take this common, you will get 1 here. So this term comes common, you will get 1 minus P of B, which is equal to probability of A bar intersection B bar. Now how can we write 1 minus P of A by using the complementary event? See here, P of A bar is 1 minus P of A. 1 minus P of A is P of A bar. Similarly, 1 minus P of B is P of B bar. Right? If you want, you can write the reason here, because P of A bar is equal to 1 minus P of A. If you want, you can write it. Fine, which is equal to probability of A bar intersection B bar. Now let me continue here. This implies probability of A bar into probability of B bar is equal to probability of A bar intersection B bar. Now you can note that, see, I'll just write it here, I'll just interchange. See, probability of A bar into probability of B bar. Now look at the equation 2. This is what we look at this equation. We have to prove A bar and B bar are independent. That is, it's satisfying the independent condition, right? Therefore, I can write A bar and B bar satisfies, or else A bar and B bar are independent event. Hence proved. I'll just repeat it once again as it is somewhat lengthy. So this is the required proof we have. So what I have done is, given condition A and B are two independent events, so that is what I have considered. So as I already told you, if two A and B are independent, we can write this condition is satisfied. Now we have to prove that A bar and B bar are also independent. That is, in place of A bar should be there, and in place of B, B bar should be there. If A bar and B bar satisfies this condition, directly I can write that A bar and B bar are independent. For that, I have considered the De Morgan's law and applied probability on both sides. So I have obtained second equation. Now this term can be written by using the property P of A bar is equal to 1 minus P of A. I have taken that as equation 3. Now I have replaced this value with this in equation 2. This is what I have obtained. Again, I have substituted the formula for P of A union B, and I have multiplied minus inside. Before that, P of A intersection B, I have replaced the value from equation 1. Fine, and I have grouped it and have taken a common factor. Again, I have applied the relation between any event and its complement. Thereby, it satisfies the condition. Therefore, I can say A bar and B bar are independent event. So, hope so it is clear. So, this completes the basic concepts regarding the probability and the rules. So, in the next session, I'll be starting with the conditional probability. Thank you. Continue in the next session.